talked about systems before. Systems are, in math, systems are two lines or two inequalities and two linear functions and how they interact with each other. In this case, we're looking at systems of inequalities. So when I look at a system of inequalities, I'm thinking about how do these two inequalities interact with each other. And the way that they're going to interact, so this year we are only responsible for systems by graphing. Now next year, when you get into Algebra 2, then you're going to have to, find systems of inequalities in other ways. But inequalities this year, so far, we only have to worry about graphing. A system, just an inequality. An inequality has a solution set. It doesn't have a solution, it has a solution set. Because it has a solution set, that means there's lots of values. So with a line, if I just had a line, and I kind of talked about this in a previous video, if I can find the paper that I wrote it on, which of course I can't. That would be too convenient. So I'm thinking, oh, it's this one. Okay. So for this one, if I have one point, so if I just have one variable, there's one point that'll make it true. For this, if I put in one x, there's only one y I'm going to get out. Now, if I change this to y less than or equal to 3x plus 5, that means when I put it in, so let's say I put in x equals, let's say if x is 1, I have y is less than or equal to 8. That means when x is 1, any y value less than or equal to 8 is going to make this inequality true. That means there's a whole bunch of points that make it true, which means we have a solution set. Okay, so when I talk about inequalities having a solution set, well, if I graph two inequalities on the same graph, I'm going to have two overlapping solution sets. Since an inequality, since a system is what value makes both of the equations true, I need values that make both of the inequalities true. So I'm going to be looking at the shaded area where the two shaded areas overlap. All right, so that means first I have to graph these two inequalities. Now, graphing inequalities is a whole nother issue. I probably ought to make a video about that. Maybe I will. I have these two inequalities, y less than or equal to negative 3x minus 5, and x minus 2y is less than negative 4. Now, the first one, again, easy. I'm going to graph it, but then I have to do the extra two things that I do for inequalities. So for graphing, I need the slope. I need the y-intercept, but then I also have to decide what kind of line I have and where I shade. Well, my line, because I have or equal to, my line is going to be solid. And since this is in slope-intercept form and it's less than means I shade below. So I'm going to plot this. And again, like I said in a previous video, when I plot, is that even right? Oh my gosh, no. 1, 2, 3, 4, 5. Okay, all right. See, we got to be precise. We got to be careful. Obviously, I was not being either of those things. We have to be precise. We have to be careful. We have to be deliberate and purposeful about our plotting because we want it to be as close to right, as close to perfect as it can be, as precise as we can make it. Now, I said that I could have a solid line, so I'm going to connect all this up and put arrows at each end because remember, lines go on forever. It said I shade below. Well, below the line is on this side of it because I put my point on and drew an arrow down. And so I'm going to shade here. Okay, whichever way now I'm not like going to like super shade it. We're not like, this isn't art. But I'm going to shade them kind of like squiggly lines. And I'm going to do the other ones in the other direction so I can see where they overlap more easily. All right, now I'm going to look at this one. Now this one's harder because it's in standard form. I can turn it into slope-intercept form, or I can use the cover-up method. I'm just going to go ahead and turn it into slope-intercept form. I'm a huge fan of the cover-up method, but it seems like a lot of my kids this year are just really digging converting into slope-intercept form, so I'm going to do what's best for them. I'm going to divide everything by negative 2. When I do that, my sign flips, so I have y is greater than 1/2 x plus 2. So I'm going to plot that. I plot my slope. So now I'm going to do the same thing. My slope is 1/2. My y-intercept is 2. My line is dashed or dotted because I don't have or equal to, and I shade. This is greater than. That means I'm going to shade above. So let's do that. So I'm going to start at 2, rise 1, run 2, rise 1, run 2. And then I'm going to go ahead and connect these. Now, since I said it was dashed, I'm going to connect them with a dashed line. So again, I just kind of do like that, do my best to do like that. Okay? And then it said shade above. So now when I do my marks, I'm going to have them go in the opposite direction. And you see how I've got, since I've got stuff going in two directions, that means the part where they overlap. Yes, sorry about that. We got interrupted. The part where they overlap, and then I disappeared. The part where they overlap is where my solution set lives. So I'm going to highlight that. Me and my highlighter. Now you don't have to highlight it. You can just look there, but I will tell you highlighting it really does make it easier to see. And I'm a fan of the highlighter. So I'm going to highlight the area where I have double shading. Okay. Now obviously, I mean, hopefully, boy, that looks terrible. Wow. But okay, just pretend it doesn't look like whatever. This is not art class, Maggie. This is not art class. Okay, so I know that this shaded area is going to continue on going that way and back that way because remember, it's lines, so this whole block forever and forever is going to be part of my shaded area. Okay, so this is how I graph, wow, that looks terrible. This is how I graph a system of inequalities. I look for the double shaded area. Now, when I'm finding my solution, I'm going to graph and shade both of my inequalities just like it is, and I'm going to look for points in the double shaded area, or points on a solid line only. Because look, if I have a dashed line and a solid line, where they cross is not a solution to both of them because it's a solution for this one, but not the dashed one. So anything that falls on a dashed line is not part of my solution set. And so likewise, so like if I look right here, let's say I look at this point right here, let's say 1, 2, 3, 4, oh my gosh, 1, 2, 3, 4, graphing is hard. Say I look at this point right here, -4, 0. That is not part of my solution set because this dashed line means I can't include points that are on that line. So it works, it's part of the solution set for this line, but it's not for this inequality, but not for this one. So because it doesn't work for both inequalities, it doesn't make both of them true, it's not part of my solution set. So we're going to look at these points right here, and we're going to plot them, and we're going to see which ones make the inequality true. I'm going to use my blue pen because it's easier to see that way. Okay, so 0, 0. Okay, wow, really? Okay. Well, 0, 0 is not in either solution set. It's not in the double shaded area. It's not even on a line. So 0, 0 is not part of my solution set. Okay, if I go over 2, up 3, okay, this point isn't even part of the solution set for the for this inequality right here for the x minus 2y less than -4 because it's on the dashed line. So that's not a solution for either one of them. -2, 1 right here. Okay, again, this is what I was talking about. See, it's part of this, it's on the solid line here. So it's part of the solution for -3x minus 5, but it's not part of the solution for x minus 2y is less than 4. So that one's not part of the solution set of this inequality, system of inequalities. So -2, 2. Oh, so close, but just outside my solution set. And 1, 2, 3, 4, 5, 3. Wow, that one's all up in my solution set. So that one is definitely part of my solution set. All right, if I look at the bottom row, if I go over 3, down 2, nowhere near my solution set, so that one's out. -3, 1, 2, 3, -3 is part of the solution set for the inequality y less than or equal to -3x minus 5, but it's not in the solution set for both, so it's not part of my solution set for the system. -3, 4. Okay, this one. So this one is kind of like when we looked here, but let's take a look at this a little more closely, okay? So this one, it's in the shaded area, so it's part of the solution set for for x minus 2y is greater than 4 because it's in the shaded area, and it's part of the solution set for y is less than or equal to -3x minus 5 because it's on the solid line, and that makes it part of my solution set. -1, -2 is this point right here. It's part of this solution set, but not the other one. It's not both. And over 1 up 5 is in this solution set, but not both. So remember, when I'm looking for solutions, now I could also have substituted one of these points, any of these points, I could have substituted into each inequality and saw if it made a true statement. So let me show you what that would look like. So let's say I use one of my true point. Well, let's use a false. Let's see. Let's try this one right here. So -1, -2. Okay. So y is less than or equal to negative 3x minus 5. So negative 2 is less than or equal to negative 3 times negative 1 minus 5. Negative 2 is less than or equal to 3 minus 5. Negative 2 is less than or equal to negative 2. That's a true statement. So it works for this one. Let's try the other one. X minus 2y less than negative 4. So negative 1 minus 2 times negative 2 is less than negative 4. Negative 1 plus 4 is less than negative 4. 3 is less than negative 4. No, it's not. So because it worked for this one, but not for this one, it's not part of my solution set. So that's the way that I would check with substitution. Any more questions you've got? Just, let me know.